Hello, my name is Eric Davis. I'm the inventor and founder of Davis Tool Systems, and this is I guess we'd call it a video to give you a good explanation of how we got from a simple idea all the way up to where we're at. So this will take a little while. I appreciate your patience in letting me get through this, but it will document a little bit about the prototyping process and the timeline, things like that. But I think it's important that you see kind of why and how these things came into life, and this is a good opportunity for me to even express it all. So I think I first want to talk about being a woodworker and find Woodworking magazine. This one was from 2012, or the 2011 edition, and I saw these stereo cabinets by Christian Bexford, and I could see how he was doing it, and I was like, wow, that's really cool. I wonder if I could do that for the whole kitchen. So instead of making it for a stereo cabinet, I made it for kitchen cabinets. And the one thing that was missing in all of this was how to sand it afterwards. I'm sure he probably did it by hand. And then here's some drawings on how I ended up getting some of the initial drawings on the damping handle. We had plenty of really interesting ideas, but let's delve into that. I'm just going to put that right here, and then here's the patents that kind of show the inner workings of it, like that. And so you'll see that in the links as well. And this is these are the current tools right there. The Grip 360 and Scraper Sander are for sale. And this is the patent for the quick connect system. So we have I'll be talking about the damping handle here, and then I'll be talking about the prototyping for the quick release adapter, and all of that will give you a kind of the timeline. There was a time that I actually called it the Sand Dancer. It felt like I was dancing with it, so I think you can see how it eventually evolved into Tango 360. So let's start with this part right here. So I have made the kitchen cabinets now. I followed the drawings from the Fine Woodworking magazine. I've got these 22 doors there, and I was using the Dremel in the beginning, and I started sanding, and it was gouging it because it was a rotary device. And so I thought, well, you know what? I'll just grab some flex hose. I'll put some adhesive hook on it. I'll then put some sandpaper on it. And then, of course, I will start going like this. And just out of a chance, I realized in 15 minutes I was just going to spend way too much time doing this. But as I looked down on the side, I saw one of my jigsaws, and I thought, well, wait a minute. That's reciprocal motion. I wonder if I could connect it. And so I found a way to take the jigsaw blade, and I made a connection for it, and I ended up cramming it into the hose and going from there. And I had at least the connection for the jigsaw. So eventually I had this. And in the beginning, I kind of held the hose like this, and of course that wasn't doing very well, so I ended up holding it up like this and seeing if I could not vibrate so much. And I thought, you know what, maybe I'll try a different approach. So I found the seam roller for the wallpaper, and I started applying the pressure, because basically I'm trying to apply pressure here into that, right? So now I'm doing this, and now my hand was a little bit more stable. So I was like, okay, that's working. Let's see it at kick it in at high speed. can see it really works well. So I saw that and I thought, but I still want to be able to flex this into that and get into these areas a little bit more. And about a year before, I made my bar stools and I was using threaded inserts. And now that I've already got the connection for the power tool and the reciprocating saw, it was like, well, wait a minute. What if I just put a threaded insert on the inside of the tube and another threaded insert into a piece of wood, and I just drilled a hole larger than the threaded insert needs, and then I'll grind off all of the threads in the middle, and as soon as I turn it through the final thread, it won't lock onto it and it will go back and forth. So I ended up having something like this, and this was the beginnings of it. I was able to send the stroke here, and now this was actually catching it and doing it, and I was able to hold it. I thought, that's pretty cool. I have to admit, somebody must have thought about that. So I started looking it up, and I couldn't find anything. I've been woodworking for a long time, so this was fairly normal to me to say this had not been done. I hadn't seen it before. So of course I started looking around, and I couldn't find it. And that was way back in 2012. And then, of course, after the sanding project was done, I started messing with the idea of different handles like this. And I could see that I had this pitch that was helping with the chamber on the inside. And I thought, you know what? Beyond that, what would really be nice would be to have this ability to have it receive the strokes, the pitch, and then also be able to dampen the vibrations. So a spherical bearing spring trapped between two split races right here. You can see it laid out. And you'll also notice here that this one has no crenulations on the quick release adapter, and I'll get to that in a second. So this was all 3D printed. We experimented with it, and we found the flaws that were within the stroke, and we tested a whole bunch of springs, and we tested everything. Tested the connection system on how to get this together and make this wheel, because this wheel is actually this wheel. So I wanted this integrated into the handle because it made sense, because I could use it in connected mode, or disconnected mode is the way I call it. So we went through, we built out all of that, and then we got to the next iteration where we have the current one configuration that you can see right now. This one was 3D printed, and everything in here was conceived so that we could manipulate any of the objects that you see here on this table, and also do it in a method that is not been seen before until I was of course doing it like this. So of course, once I saw that I could use it with a profile sander, like something round, I knew that any geometry wouldn't matter. So whether it was flat or flexible, and I thought, well, I just want to see how flexible I can get it, and that was where the strap sander comes in. But I'm gonna show that in just a second. But I kind of want to keep with the process of the development. So once I realized that I could put anything on this, I knew that I needed a better connection, because the jigsaw blade was breaking. And so I went and I found the competitor's tool, and they have a reciprocating saw blade right here. And of course this comes with a replaceable blade because, yes, they break. So, but it had this quick connect on it, and I thought, well, hex key, okay, I get it. We could put their brushes and all their stuff on it. So I played with this idea, but there was way too many vibrations and way too many connections. So I thought, we need to simplify this. We need to get a better connection on a power tool that has one connector that makes sense. And so in comes the quick connection system that we have started with. So once I started investigating all of this, we ended up making this one here. And this was with an air hose connector right here. So we have the grooves, and now we had the ability to connect a real solid connection here, and it would still rotate. And then we made some connectors like this, and that was convenient enough, but it was still a little bit too big. So we moved on, and this turned into this one right here. So this was a lightweight 3D printed one that we could check and manipulate. And you know what? It worked, but there was one problem. It kept rotating. The times that I would test something that was flat, it would always, the power tool would kind of twist and turn, and before I knew it, I was looking at this air hose connector going, how can I fix this? Why can't I just make it fixed position? So me and the engineering team put to the task, and our first iteration of that actually was this is what we call an annular groove, and these are ball detents. So inside of the adapter you have ball bearings, and well, if you just displaced it, the ball bearings would hold into it in the detents, and you wouldn't even need any crenulations for that. So we have the freely rotating position here and the detents version right here. And one of the problems is we have shear strength. The ball bearings being put through the test here need to have shear strength, and that is that they won't break or pop out when they're in operation. So we had to make sure that they were robust, but I knew that it was probably still not enough for what the power tool was going to give to it. So I stared at it again, and I'm looking at it, and I'm like, I need a different way. And then I could see the crenulations and the opposing crenulations right there. So interlocking crenulations and two annular grooves, fixed and free rotation. And once I got that initial idea going in 2018, somewhere around 2018, that changed everything. I had to stop what I was doing and file another second patent. And that second patent included the detents version in this one, and we've been awarded the crenulated version, and we're still waiting. It's still pending for the detents, but that's a long process, so it's okay. In any case, once I realized that I had this fixed and free rotation, I knew it was game changing. And I know you know that too, because you can see it, just in any, interaction, right? This is the way any scraper would be. You would always use it in the same way. But now, pull it back, and let it spin, and now it's just more ergonomic. You have the human interaction element is so much more better. And so it was very convenient to say, okay, well, now let's figure out how to make some some accessories that can take advantage of this, and it started to just explode into so many ideas. And it takes a while to get through those ideas. So let's just start with all of the possibilities of the rigid side right here, because you know, I can show this fairly quickly right now. With a single connection right here, even a profile sander can be used in any way, right? So let's just connect the damping handle right here to a profile sander, okay? And let's just say I'm going around something, and I'm not going to put it on high speed so I don't have to, you know, totally at this, but let's just say I needed to sand around something. And then get into something. And that then in turn allowed me to say, okay, well, let's see what the rigid connections look like. And so this is one of the products that is up and coming. So this, we call it the rasp sander combo. This in freely rotating position, right? So here's the rasp, and I'm just gonna, you know, dig off a little bit. And then I'll just flip it over and sand it. So it's pretty straightforward, you know. You have adhesive hook with the sandpaper, and you can just change that out. And, you know, if the adhesive hook becomes no good, you just replace it. And then of course you have the fixed position. So lock it in, and now you have a little bit more power to do what you need to do. And then of course, if you need to still stay in that disposition, flip it over. And now this tool, you know, of course it has a detachable battery, 12 volt 2.5 amp hour, and 6 speeds on it, plus a articulating head. So this one we had conceived. This is a sander. It is not a jackhammer. So we first experimented with what's the mass and the weight that we could get away with. You know, how far can we do this? So we made this super heavy scraper that we knew would, at high speed, like this, if I had to sand, I have the lateral pressure right here, and that enables me to get so much more than what a jigsaw blade would hold, because these will break under that load, but this one won't. So now it was, okay, well, what can we do? You know, how far can we take this? And so this was our first effort. And then, of course, we wanted to, you'll see my shutters over here. I use that in a lot of the videos. In order to get through tight spaces, especially, there's so many chairs, shutters, you name it. There's so much out there that I needed something that would simulate a blade tang, and that was this. We call this the S-tang. And so we developed our own system where you basically just hook it onto the first pin right there, slide it around, and you're in. So you could actually go through just about anything. I'll call it 4 or 5 millimeters, and then lock it in place like this, put it in, and so this one would end up in the power tool. I will put it in free rotation. This one in the damping handle, and that it always remains in free rotation. So you can see that I have very much a 3D environment that I can work in. And in this case, I'm just going to show it like this. And this is high speed 6. You can see this hand is being stabilized. There's always vibrations in a reciprocating tool, but you don't have to hold it so tight that you're letting it go. So here we go. And that's sanding. I'll just go over there, I'll just rasp it a little bit. And then come back and sand it again. So that was the rigid part, and you know, and I kept looking at this and I'm like, well, how flexible can I go? Of course. And so that just kept asking the question. So let's answer that question while we're here and get the strap sanders on there. The strap sanders were purely a, you know, an idea that came out of this because of just testing it, and you know, that was where I was hoping for. So I'm going to use this this one as the tester for you, or just the example, and you can see that you know, this could be any staircase, right? And you'll notice that this is, I have choices of strap sander sizes. So in the beginning, I had just developed the strap, and I had some different buckles and things like that, and they kept fraying. It kept just not, it wasn't lasting, and of course I wanted something that would work and last. So I really had come up with, at one point, I never had the tube around the strap, but I realized the tube around the strap was now going to allow it to flex and rotate the way it should. And I thought, well, that's great. So let's take that to the next level. And we ended up with this connector, so that we have rivets. We've sewn in the adhesive hook. This one, you're going to see I have 2 different grits of sandpaper on it right there, so you can just flip it over and go. And this is a good example, probably for a second, just to show that our initial product, the Grip 360 right here, is this is fixed position, okay? And so, like a jump rope, it will just bind on itself, right? But when you're in free rotation position, it's like a jump rope in a way. And now it's very maneuverable. And if you had to sand something all the way around, you could. And it goes I'm doing this because we need to speak, so yeah, wear a dust mask when you can, okay? So that is the ability to do it by hand, of course. And you know, we understood this a long time ago, that we would put it on there, even put it on extension poles and go beyond. But of course, I wanted to automate that process, right? So this was the damping handle. I wanted to see just how far I could take this this idea, and I'm not. I'm going to put it in free rotation, and I'm not doing very much pressure on this. Okay, so you can see it definitely makes a lot of. So it's super simple. And of course, if I wanted to go all the way around, I could, just like this as well. And you can see that the damping handle inner spring is what is sending the stroke back out. Right there. So it was, you know, at the time it was just like, wow, that's pretty fun. I enjoy that. And then it was like, okay, well, there's so many different abilities to sand. How far can we take this? And so we had, of course, the strap sanders. And then that whole seam roller thing came back into mind, and foam sanding blocks. And so profile sander, you go all the way through it, drill, cut a hole through my foam sanding block, plug it into my system, and I thought, well, what about that, right? And I wasn't getting the pressure, so I wanted to show that, yeah, I could do it like this. And that worked. And I thought, well, wait a minute, I could do it on walls. Of course, I could do it on anything. So there was a continuity with this idea. And then, one of the advantages that I could see was that the crenulations could provide torque. So here we go. I ended up putting the hex bit adapter that we were describing, and I ended up saying, oh, okay, well then I can just put anybody's tools on this thing, right, and still brush or still do anything. And I thought, well, wait a minute, what about screwdrivers and things like that? And whether it's wrenches or screwdrivers, I can extend all of that and still, provide the ability to make a small pack out. Like if you didn't want to bring a whole bunch of tools on the roof, you could just bring the small handful that you need and scrape something, turn some screws, and do that. Your pack out would be super small. So to me, that was a kind of a self-evident idea. And then, when we were making this, I had already understood that crenulations provide torque. So these quick release adapters, as they were being made, it begged the question of, well, if a multi-tool has crenulations, then can I weld mine on? Now, I've bought and destroyed more tools than you could imagine, and put my adapters on it, and so this was my test. So I put the 5mm threaded adapter with my crenulations here, and I put it onto this this multi-tool here, and of course you can see here, I'll put it a little closer, that the crenulations provide the torque, and that I could do that. So I understood quickly that, yeah, I could do that, and that would then therefore mean that I could make my profile sanders could work with this as well. And so I thought, well, wait a minute, does it work? And it does. And I thought, well, wait a minute, if I had one doing that, let's destroy another tool and see if we can do it there. And there it was, in parallel. It was amazing. I was able to do all of this just continuously, and be able to say, well, okay, so if we can put the Davis connector on reciprocal, turn this into a reciprocal multi-tool, then can't we take the multi-tool and turn it into a full accessory kit? And even then, I could put this with the damping handle, and I understood that. And then I was like, well, I could put it on any reciprocating device, and I could make this as big or as small as I want for that purpose. And all of these ideas were just, continuously flowing, and that in turn, it just says, well, what exactly could I start selling right now to give somebody? So it was the Grip 360. We have that on our website right now, but I knew that this whole kit you had to have a minimum amount of stuff in order to experience it. And that's what this Kickstarter campaign is all about. That's what we're here for, is to give you the minimum amount of stuff that gives you the maximum amount of experience with it. And even if you take, for instance, the profile sanders right here, I 3D printed with some TPU different profiles, and I was able to make it, of course, just like this. And now I can, it doesn't just have to be a round one, it can be, you know, any shape that we need. And now I can automate that for profile sanding into, you know, all these little spots and make, you know, different places for that. So it became quite obvious to me that there was such a multiple usage for this, you know, riffler rasps, make it power, not make it power, rat tail rasps, half rounds, you name it. And then I had, and of course I have Kutzall rasps, and I also had their shaping wheel, and I had them make this beautiful Kutzall one here. And this one, it was just amazing. I could see that I was, you know, these carbide rasps. I call it. This is my rasp sander, the Kutzall rasp sander. And so here you can see me sanding right here. But you know, if you're a carver or a shaper or a sculptor or anything like that, this thing. These carbide teeth will just really take care of some business really fast. So this is another one of the wonderful tools that we have. And then of course I was experimenting with chainsaws to, you know, cut down tree limbs and things like that on the forest. And even different abilities to turn something like this is just the sanding bar, and this is the adhesive hook that's attached to it. So you can see right here it's just a straight up metal bar, but you attach the adhesive hook to it, and you know, even here I could take this and then I could get a foam sanding block, and then I could still apply the pressure, and there were just so many different methods, and to me that was a big deal. And then there was different connection systems that I had to develop in order for this to come to life. So different products, and we had experimented with all of the different types of steel, but I knew that this was not a jackhammer and it was not a jigsaw, it was something in between. And so here it is, the hybrid of it all. And you know, there's, as you can imagine, I'm showing just a little bit of what is going on, but there's a whole host. I've got 5 boxes of stuff over there that I wish I could show everybody. But there is a reason that we win all these awards. It's the damping handle, the quick release adapter, all of this is just allowing the human interaction of reciprocal or multi-tool actions to manipulate almost any object in between. So, you know, there's so much, you know, different ways to turn reciprocal action into oscillating action just with using a universal joint, or even just something flexible. So the whole system has the potential to solve different problems in different ways. Are you going to throw out your old tools? No, and I wouldn't expect you to. But there's a pretty good argument to say that the Davis connector itself is an incredible solution to diminish the amount of tools that you need. And, you know, Eric Davis here, so I had to come up with an acronym, and the Davis connector, that is Dual Action Variable Instrument Systems, of course. So if you've made it to the end of this video, congratulations. And I do have, you know, I mean, I could make this go on and on, but I wanted you to see the wide variety of choices that you could have. And I hope this helps you understand that this is just the start of something new. It's the beginning of a whole new era in human interaction with tools. So thank you very much. Of course, always help out by signing up and buying into Davis Tool Systems. Thank you.